In engineering graphics or engineering drawing as you call it, after lines which happen to be the basic entity in case of any object or the solid or plane that we are talking of, the second important entity which we should be discussing is the plane. The planes which we are going to talk of over here, or the projections of planes, will be considering the planes which are either rectangular planes or triangular planes or pentagonal, and we will be generally talking about the regular polygons. Let us consider a simple problem. A triangular lamina ABC has AB equal to 40 millimeters, BC equal to AC equal to 70 millimeters, is resting on AB in HP. It is inclined at 45 degrees with HP and side AB makes 30 degrees with VP. Draw projections. A typical problem on projections of planes. Some rules which are to be remembered. First one, determine line of rotation for the plane. That is the line about which the entire plane is rotated. Number 2, with line of rotation perpendicular to XY, place the plane completely in HP or VP as the case may be. Therefore, the other view is line view on XY. Perform the rotation that is line view and obtain new view. Finally, show angle made by any line that is specified in the problem. So with these steps, if we start solving the problem, as the lamina is going to rest on side AB in HP and it is making some angle with HP, you can always remember that the lamina should be kept in HP and then should be rotated, and line of rotation, that is AB, because that line is not going to move at all. So we will consider AB as line of rotation, and line of rotation should be always considered as perpendicular to XY. we will mark point A, measure distance equal to 40 and mark point B. As BC and AC are of same length, we can very well mark or cut two arcs of length 70 each and obtain the actual shape of that lamina ABC, and it is kept in HP, and that's why the elevation or the front view will be on XY. So we will get point A dash and B dash on XY and point C dash also on XY. Remember that the starting step will be to draw true shape, that is, keep the lamina in one of the reference planes wherever either a point or a line is resting. Now the lamina makes 45 degrees with HP. Angle with HP will be always seen in the elevation. Angle with HP should be always seen in elevation, and line of rotation will be always marked as a point, and in that case we can rotate the line which is actually representing the plane. So draw an angle of 45 degrees, take this much distance in the compass and cut one arc. We get new position for point C. Rotation in one view is movement parallel to XY in other. So point C will start moving parallel to XY, and then we can draw projector through C dash. Wherever it cuts the path, so I am drawing projector through C dash, wherever it cuts the path we will get point C. And then we can finalize the elevation, which was the line view, and the plan. Of course, the original point C can now be numbered as C1 and C1 dash. It is given that line AB should make 30 degrees with VP. Angle with VP will be seen in plan, but in plan right now AB is making 90 degrees, so we are required to redraw this figure with AB making 30 degrees with VP. So we have actually finalized the shape of the plan over here. Now we will draw a line at 30 degrees. Take a distance equal to AB in the compass and mark points A as well as B. And then you can take a distance equal to BC and AC, and you can very well mark point C in plan. Observe that it is as if we have rotated the figure in this manner, so that it makes 30 degrees with VP. Line AB should make 30 degrees with VP. Again the same rule, rotation of one view is movement parallel to XY in other. So A dash, B dash, they will move parallel to XY, as well as C dash will also move parallel to XY. And then if we draw projectors, this will be projector through A, projector through B, and this is going to be projector through point C. We can finalize the points of the elevation C dash, A dash and B dash and join them, where we get the final elevation. So here we had one rotation in the elevation, movement parallel to XY in the other view, finalize plan, then rotate plan, movement parallel to XY in the elevation, finalize elevation, and so on. This is the procedure. So far as dimensioning is concerned, you are required to show the actual dimensions which are given to us. So AB was 40, BC was 70. So all these distances are to be shown. Angles we have already marked, and this will complete our problem, that is projection of the triangular lamina as per our specified rules. After considering the problem for triangular lamina, let us proceed to a problem of pentagonal lamina. The problem says that a pentagonal lamina of side 30 is resting on one side in HP, which makes 45 degrees with VP. That means the side is making 45 degrees with VP. The lamina is making 60 degrees with HP. Draw projections. Now to solve this problem, as again the lamina is resting on one side in HP, that side should be initially considered as the one which is to be drawn perpendicular to XY. Because if the lamina is to be rotated, when we initially keep it in HP and we start rotating it, one side we will be holding and it will be kept in HP. So ultimately the lamina will be rotated about that side, so it becomes the line of rotation. And if it is the line of rotation, that should be initially drawn perpendicular to XY. So let us draw the pentagonal lamina. As the side is in HP, we will be keeping the lamina in horizontal plane, and then the top view will show us the pentagonal lamina in its true shape, and the front view will be simply a line view on XY as in case of the previous problem. So first we will start with XY line, and then we are required to draw the pentagon with its side perpendicular to XY. So take a distance equal to 35 millimeters. Take a distance equal to 30 millimeters, I suppose. It is side of the pentagon. Mark 30. Then you can measure the internal angle, which is 108 on both sides. And then you can mark the sides as 30 mm on both the angles. So you take distance equal to 30 and mark on each one of them, and from those 2 points you can cut the arc to complete the pentagon. So we can draw the pentagonal lamina in this manner. With side as 30 millimeters. These points should be named A, B, C, D and E, and then we should be drawing the projectors. And we will get the front view on XY, which is A dash, B dash, C dash and E dash, D dash. Initially line of rotation is been drawn perpendicular to XY. It's a regular pentagon. Internal angle, I repeat, is 108, need not be shown. Now the lamina makes 60 degrees, so we are required to draw a line at 60 degrees and then transfer these distances. So I want you to rotate these 2 points and mark them again, C dash, this is C dash and E dash and D dash, and finalize them. So it is rotation in the elevation will result in movement parallel to XY in plan. So point D will move parallel to XY, point E will move parallel to XY, point C will move parallel to XY. A and B are not going to move because we are performing rotation about them. Then draw projector through C and E, and also draw projector through D. Now the respective intersection of the path and projector, will give us the points of the plan. So this will be point D, path of D, projector of D. This is path of E, projector of E. This will be point E in the plan, and this is point C. And then we can get the final plan, the shape which will be no longer the regular pentagon as such. Will be having 5 sides, but will not be the regular pentagon. That will complete our first task. Now it is given that the side on which it is resting is not perpendicular to XY, but it is making 45 degrees with VP. So we are required to choose some point on XY from where we will be drawing a line at 45 degrees. So draw a line at 45 degrees, and then to reproduce this new figure, instead of using the method of arcs, I will first of all enclose it in a rectangle. So this is the rectangle, don't number it, this is just for your reference I am numbering it. It is 1, 2, 3, 4 is the rectangle, and I want you to take distance equal to 1, 2, which contains AB, and that should be marked. Take a distance equal to 1, 2, and that should be marked on that 45 degrees line. Using drafter you can very well draw perpendiculars. These perpendiculars are representing these lengths 2, 3 and 1, 4, which is one and the same. So it can be drawn. Then you can take a distance equal to 1A, which is same as 2B, and mark. You can take distance equal to 2C, which is same as 1E, and mark it. And then you can take distance equal to 3D and mark it. So we have got all the points using rectangle technique, which are to be joined by the full and final lines as such. This is the rotation of plan, again by 45 degrees in this case, as is given in the problem. This angle is 45 degrees. The angle through which we had rotated the line view, that angle was 60 degrees. So this is rotation in one view, is movement parallel to XY in other. So points C and E, they will move parallel to XY. Point D will also move parallel to XY. So rotation in one view is movement parallel to xy in other, and to fix the points we should be drawing projectors. This is projector through A. Up to path of A, it will be point A dash. Projector through B, up to path of B, B dash. Projector through C, up to path of C, C dash. Projector through E, up to path of E will be E dash, and finally projector through D up to path of D will be point D dash. And if we join these 5 points in the same sequence, AB, BC, CD, DE and EA, we get the final projection of that particular pentagonal lamina. In dimensions, we are required to show only the true length of one of the sides, which is 30. Mark XY line, don't forget to mark that. These arrows are actually our references, which we will not be drawing in the final exam. And then this will be the solution of the problem for pentagonal lamina. Procedure I will show you once again. And in this procedure we will be just marking the steps which we have performed. We started with the regular polygon, that was our step number 1, with the line view on XY. Then we had drawn this 60 degrees line. On that 60 degrees line, we had rotated points D and C and E. So these rotations was step number 4. Rotation in one view, movement parallel to XY in other. So drawing these paths is our step number 5. Dropping the projectors was step number 6. And drawing the final shape was step number 7 with darkening. So it was, the figure is drawn, then it was projected up to obtain the line view. Line view is rotated, points are taken down. It has resulted in movement parallel to XY in the other view, that is in plan. And we have finalized the plan. Then we have constructed the rectangle, that was our step number 7. We had drawn this angle 45 degrees, is step number 8. Reproducing the rectangle, step number 9. Reproducing the plan, step number 10. Then we had drawn path through each point of the elevation. This is step number 11. Projectors, which we have stretched from here, is step number 12. And finalizing the elevation is step number 13. previous two problems which we have solved of planes, we are given the angle made by the lamina with HP. Consider this problem where it is stated that a rectangular lamina of side 30 and 50 is resting on smaller side in HP. The lamina is inclined to HP in such a way that top view is a square. Draw projections if side in HP makes 35 degrees with VP. Now in this case, we are not given angle made by the lamina with HP. The lamina is resting on one side in HP, and as we start rotating the lamina, we know that its shape is going to reduce, because the other 2 points, they are going to move towards the points about which we are rotating it, and at one time it is bound to become 0. So the top view will be changing the shape continuously, and we want to stop at the point when the top view appears as a square. So in this case, we cannot perform the rotation as the angle is not given, but we can draw the final plan, and from there we can find out what should be the angle made by the plane. The problem will be solved in the similar manner in the initial stages. Line of rotation is the smaller side of that rectangular lamina, and that should be drawn perpendicular to XY. So we will start the solution by drawing XY line. Line of rotation is drawn perpendicular to XY, on which we will have 2 points spaced 30 apart. And then we are required to draw the rectangle of side 50 here. So this is the rectangle of side 30 by 50. True shape is drawn in plan. Name it as, say, A, B, C, D. So this will be A dash, B dash, C dash, D dash. This side is the smaller side, 30. This is the longer side as 50. As we start rotating it, suppose this starts rotating, we know that C and D are going to move parallel to XY. So they will move along these lines. When should they stop? So that it will form a square. Now one side is 30, so these two sides, they should stop at the point where it will appear as a square. So the entire movement will be of 20 millimeters, and this is the final position of point C and D after the rotation, and the top view will be a square. Our procedure was to get C and D through the rotation, but now C and D are available. We will draw projector through C and D, and the line view should be rotated so that C dash D dash should be on this line, and so when we perform the rotation, so it was this step drawn first. You complete the plan, go up, perform the rotation. Wherever it cuts this projector, we get the final position of points C dash and D dash. And this is the angle made by the plane with horizontal plane theta, which can be measured. Once this is completed, then the rest of the part is easy, because now we are required to draw AB at 35 degrees. So we will draw AB at 35 degrees. Draw perpendiculars and complete the square. So rotation in plan now. it will be A, B, C, D. Preserve the same nature of naming it. I am naming them in anti-clockwise manner. Rotation in one view is movement parallel to XY in other. So points C and D, they will start moving parallel to XY. And then draw projectors. Projector through A up to path of A. This will be point A dash. Projector through B up to path of B. This will be point B dash. Projector through C up to path of C will be point C dash. And projector through D up to path of D will be point D dash, and they should be joined in the same sequence. Will be the solution for this problem. The only change in the previous problems and this problem is that we are not given theta directly, and so it was plan that was constructed first, from which we got the elevation. If required, angle made by the plane with HP theta can be explicitly written. You measure it and write it. It's the reverse procedure. So first we obtain the plan. Step number 1 is to get the final shape of plan, which is square, and then we complete the rotation too. In all other cases it is rotation first and then the plan. The next problem, again we are not given the angle made by the lamina with HP. It is given that a hexagonal lamina of side 40 is resting on one side in HP such that the opposite side is 30 mm above HP. The side in HP is parallel to VP. Again, reading this problem gives us the idea that as it is resting on one side in HP, that particular side will become the line of rotation, which is to be drawn initially perpendicular to XY as per the procedure that we have already written. And so when we start with XY line, draw a line perpendicular to XY, and then we are required to draw the hexagon with one side perpendicular to XY. The side of the hexagon is given to us as 40. So the hexagon can be constructed. It can be done other way around also, that you may draw the circle of side 40 of radius 40, and then using the arcs you can complete the hexagon, or you can measure the internal angle as 120 degrees and complete the hexagon. Whatever procedure that you follow, it should appear as a regular hexagon. That is one and the foremost thing, because though you will be drawing it only from one side, the examiner can see your hexagon from any direction as he wants, and that symmetry has to be observed. Naming is also essential. We normally name it in the anti-clockwise direction. True shape is drawn in the top view. Draw projectors through each one of them and get the line view of this lamina, which will be on XY. The side of the hexagon can also be shown at the same time, so we don't have to dimension it again. This was the line of rotation that we were discussing earlier, which is drawn perpendicular to XY. And now as we start rotating the line view, it is given that the side opposite to side in HP, that means side DE, it should be at a distance 30 mm from HP. Of course, in the elevation, XY line itself will be considered as the horizontal plane, and this D dash E dash point, it should move up and it should achieve the height of 30 millimeters, and so we can draw a line at 30 millimeters at a distance equal to 30 millimeters from XY, and then using compass you can rotate and join this. This will be the final point D dash E dash, and also C dash F dash are to be rotated and marked. As per our rules, rotation in one view is movement parallel to XY in other. So all the points in the top view, they will start moving parallel to XY, and then we will drop the projectors through point C and F and also through point D and E, and we can mark the final points. It will be F, we will have point E, point D, point C, B and A. So the earlier points can be now numbered as the first points, that is C1, D1, E1, F1. Of course, this will be C1 dash, F1 dash, D1 dash, E1 dash, and the new points are again named C, D, E, and the original points A, B, they remain in their position. Now in the problem it is stated that the side which is in HP, in our case it is side AB, it should be perpendicular, it is drawn perpendicular to vertical plane initially because it was line of rotation, but in the problem it is stated that it should be parallel to VP, so we are required to rotate this new plan such that AB becomes parallel to XY line, and for that purpose, instead of going for the method of arcs, we will be again enclosing this figure in a rectangle and numbering that rectangle as 1, 2, 3, 4. We can choose any arbitrary line parallel to XY on which we will be marking the length 1, 2 as such, and on that 1, 2 we can mark all the points like point A, then point B, and then of course point 2, and then complete the rectangle. Height of the rectangle is also known to us, 2, 3. You can mark that height. So the rectangle can be drawn. You can mark the midpoints of that rectangle, and of course through the construction only, through these parallel point lines only, you will be getting all the points like A, B, C, D, E and F, and join them to obtain the final plan with AB parallel to VP. This is again considered as the rotation of the plan, and rotation in one view is movement parallel to XY in other. That was our first important rule, and so all the points, they will start moving parallel to XY, and these will be respectively the paths for point C and F and path for point D and E. Draw projectors through each of these points. And you will get point A dash, B dash, C dash, D dash, E dash and F dash. Join them in sequence to obtain the final elevation. That will be problem number 4. And in all these 4 problems, we have dealt with only the case when one side of that polygon was resting on HP, and that itself was the line of rotation. Again, in this case, angle made by the plane with HP, that is angle theta, was not given to us. So in the last 2 problems, this and the previous one, are the cases where angle made by the lamina with HP was not given to us. We had to find it every time, and you are required to also write the answer by measuring that angle. That will complete our first case. This was case number 1, talking about side in HP. In the next case, we will talk about corner of the lamina in HP. A circular lamina of diameter 60 is resting on one point of its circumference in HP. The lamina is inclined at 50 degrees with HP, whereas diameter through the point in HP is making 30 degrees with VP. Now, as one point of that circular lamina is in HP, we are required to keep the lamina in HP, and hence the top view of that lamina is going to be a circle. So we will start the solution by drawing the circle of diameter 60 in the top view. This circle should be divided into 12 parts. Not only that, all the 12 parts should be numbered, because to draw the smooth curve afterwards we require these 12 points, otherwise it will be a tough task. So the circle is divided into 12 parts. And even all the 12 parts, they should be numbered. So this is point number 1, point 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. As the lamina is kept on HP, these points, or rather this line, will be the front view of that lamina, starting with point 1 dash. This is 2 dash, 3 dash, this will be 4 dash, this is 7 dash. I am not naming all the points, it is unnecessarily becoming complicated otherwise. And then we are required to rotate this lamina, so the line view can be rotated so that it will make 50 degrees with HP. Angle with HP will be seen in the elevation. So in elevation we are required to mark the angle 50 degrees, and then we are required to transfer all these points. All the points should be transferred. And so this becomes the front view of that lamina after rotating it by 50 degrees. So this will be new point 7 dash, this will be 4 dash and 10 dash. Now you are required to name all of them. It is 2 dash, this is 3 dash, 4 dash, this is 5 dash, 6, then 8, 9 dash, this is 11 dash and 12 dash. Rotation in one view is movement parallel to xy in other. So in top view, the points will move parallel to xy. All the points are going to move parallel to xy, including points 4 and 10. All of them, they will start moving parallel to xy. So we will mark one by one. Point 7 should lie on this projector, and 7's path is this one. So we finally get point number 7. Point number 6 and 8, we will have to first of all draw their projector, and their paths are cut at these 2 points. Point number 5 and 9, draw the projector through 5 dash and 9 dash till that projector intersects the respective paths. Point number 4 and 10, so we get 4 and 10. Point number 3 and 11, so we get point 3 and point 11. Point number 2 and 12, we get point 2 and point 12. And these are the 12 points which are now to be connected by a smooth curve, a symmetric curve also. This is going to be the ellipse that we are going to get. So in this case, the top view comes out to be the ellipse. Now this ellipse is to be redrawn. This ellipse is to be redrawn so that the diameter through point in HP, that is diameter 1, 7, should make 30 degrees with VP. Now as it is given that diameter 1, 7 should make 30 degrees with VP. Obviously this angle will result or will be seen in plan only, that is in top view only. But we will have to check whether we have the true length, and we find that 1/7, as we are getting it over here, is not the true length, and therefore we are required to construct the apparent angle, because true length will be associated with true angle and apparent length will be associated with apparent angle. And for that purpose we will choose some point, and from there we will draw the true angle, that is 30 degrees. On this 30 degrees, take the true diameter 1/7 and mark it. So we can mark the actual diameter of it. And then get the path. Our standard construction. So this was the actual diameter. And now take the new diameter that we have got, new length of 1/7, and from this fixed point cut one arc, and we get the new position for 1/7, the new angle. Once this angle is fixed, then to reconstruct the ellipse, we will obviously be constructing the rectangle in which this entire ellipse was located. So first of all, construct the rectangle in which the ellipse is to be drawn, and then transfer all the distances. We want to simply generate the same mesh in that rectangle. So we are simply reconstructing the entire mesh that was there through the horizontal line as well as the projectors. And then we can get the points. This was point 1, then this is point 2, 3, 4, 5, 6, 7, 8, 9. This was point 10, 11 and 12. And now these points again can be joined by the smooth curve. So that the same ellipse has been redrawn. Naming is always essential. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The construction should be retained, because otherwise we will not be getting marks. So this angle, apparent angle that we are getting for 1, 7 is bound to be greater than 30 degrees. And now rotation in one view will result in movement parallel to xy in other. So we are required to now draw paths. This is path of 7. This is path of 6 and 8. This is path for point 5 and 9. Path for point 4 and 10. Path for point 3 and 11. And path for point 2 and 12. Rotation in one view is movement parallel to xy in other. And once we draw these paths, then we are required to mark each point one by one. This is projector of 1, path of 1, we get point 1. Projector through point 2, path of 2, we get point 2. Projector through point 3, projector through point 3 up to path of 3. Projector through point 4, up to path of 4. Projector through point 5, up to path of 5. Projector through point 6, up to path of 6. Projector through point 7, up to path of 7. Projector through point 8, projector through point 8 up to path of 8. Projector through point 9 up to path of 9. Projector through point 10 up to path of 10. Projector through point 11 up to path of 11. And finally projector through point 12 up to path of 12. So we will be getting the 12 points, starting with point number 1, then point number 2, 3, 4, these are all elevation points, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and 12 dash, which are to be connected using French curve by a smooth curve and then we will complete the problem. Remember, there was a construction of apparent angle which you cannot forget. Need not be drawn externally, we can simply have it inside that particular figure. Is the projection of a circle minimally to be divided into 12 parts. It is essential that we will have to divide every circle into 12 parts, otherwise we will not get the required smoothness. The figure has been transferred using the rectangle technique. And also observe that I am not arbitrarily drawing the projectors. I am taking every projector only up to the respective path, and the paths might be extended. Only the final two ellipses, they should be drawn dark. Everything else is a construction, should be kept as light as possible. We don't have to name the views as front view and top view. Diameter is the only dimension which is to be shown. And that diameter is given to us as 60. Being a symmetric problem, sometimes we even show the center lines, but on construction line it becomes a bit difficult task to show the center lines. This angle also is to be marked. It was given to us as 50 degrees. It is seen as 50 degrees. No need to show any arrows or anything like that, though we are rotating it in this manner. Naming at times can be avoided, or some fractional or partial naming can be done. Like over here in this new view, I am not naming all the points. Few points are named, few points are left. Final figure should have the proper numbering. So we are considering the case where corner should be kept in HP. Another problem, a hexagonal plate of side 30 is resting on one of its corners in HP, and the plate makes 40 degrees with HP. One side through point in HP is parallel to VP. Draw projections. In this case, we know that the lamina should be kept in HP, but then this hexagonal lamina should be put in such a way that line of rotation should be perpendicular to XY, and for that purpose, actually to draw the hexagonal plate, we will be drawing the circle first of radius 30. We should be drawing the circle of radius 30 and then deciding as how the hexagon is to be drawn into it, because that is the simplest way rather than measuring the angle 120 degrees. Now hexagon should be drawn in such a way that the rotation about corner should be possible, and so we take the radius and cut the arcs from here, getting the points for the hexagonal plate. And this is how the hexagonal plate initially should be kept, so that the two sides of this hexagonal plate, they will be parallel to VP, and this corner is exposed, about which we will be performing the rotation. So initially, if we name it as A, B, C, D, E and F, then the front view will be on XY, A dash, these are points B dash and F dash, this is C dash and E dash and D dash, and then about A, so this is the line of rotation, we will be rotating it so that it will make 40 degrees with HP. We are required to mark all these points. So we will be performing the entire rotation, and these will be the new points B dash, F dash, these will be C dash and E dash, and this is D dash. Rotation in one view is movement parallel to XY in other, so these points will move parallel to XY. D dash point will be over here, D point. Points C and E, they will regain the new position at these 2 points, whereas points B and F, they will be taking the new positions over here, and ultimately the new shape of that hexagonal plate in the top view will be again the hexagon only, but will not be the regular one. So this will be the final front view after the first rotation is performed. Now it is said that some side, that is the side which passes through the point in HP, A happens to be the point in HP. So through A we have two sides, AB and AF. One of this side should be parallel to VP. Anything that is parallel to VP will be parallel to XY in plan, and so we are required to draw a line parallel to XY and decide which one of these two should be drawn parallel to XY. I decide to draw AF parallel to XY, and so mark the 2 points A and F. But with this AF side, which is marked over here, if we are to reconstruct the entire plan, the best way will be to first of all get this point, this corner, so that it will be possible for us, if you can get this right angle triangle from here at this position, then the job will be simpler. Then the job is going to be the simple one, because we can now construct the rectangle of these sides. Excuse me. So FE distance can be marked onto this. So you can get point E. Similarly, this distance can be taken further and the rectangle can be completed. We can draw a line through this to obtain point D, and of course if the same distance is plotted here, we can get point B as well as point C, and then we can say that the same shape has been reproduced. So this hexagon we have reproduced. Rotation in one view is movement parallel to xy in other, and so we will be drawing paths through these points, and then we will mark point by point each one of them. Point A, so this will be A dash. Draw projector through B up to path, this will be point B dash. Projector through C, in this case it is coinciding, let it coincide. We will have to check it with the actual dimensions earlier. Point D and F in this case are coinciding. They may coincide. So we get point D here and point F is over here, whereas point E so this is C dash, D dash, E dash and F dash. This was A. These are to be connected in the same sequence. And we complete the projections of the hexagonal lamina when it is resting on one of its corners in HP. So the procedure remains the same. Only thing is the starting position has to be taken correctly. Of course, the rotation I have performed in the anti-clockwise direction, you can perform it in clockwise direction. Still the solution will appear to be the similar.